This problem involves traversing a binary tree. We're asked to write a new method for the int tree class called inOrderList that returns a list of integer containing the sequence of values obtained from an in-order traversal of a tree. So for example, given this tree here, an in-order traversal would begin with its left-hand subtree, which would give us 29, 42, 6. That's why we see 29, 42, 6 here first. And then the overall root value, the 17, and then an in-order traversal of the right-hand subtree, which would be 81, 9, 40. 81, 9, 40. So we're supposed to return this as a list of integer from the call on inOrderList. I have set up a JGrasp file that we can use to test this. It constructs trees of various sizes, and it calls the print inOrder method that will show us what the inOrder traversal is. And then I'm making a call on this method, the inOrderList method, which is supposed to return a list of integer, and then I'm printing out what comes back to make sure that what we get matches what we see in the call on the print inOrder method. So I have over here the int tree class that constructs the sequential tree, so the simple version of this int tree class, and this is the method we're supposed to write, something called inOrderList that returns something of type list of integer. So we're going to have to deal with some constructing of a list here. Now we immediately run into the problem that we want to have a private method here because we're going to want to be able to call this on various subtrees of the overall tree. We're going to want to be able to manipulate just the left-hand subtree or just the right-hand subtree. So we're going to want to have a method here, a version of this that we can also call inOrderList, and that will take an int tree node that we could call root, for example. So we want to have a different version of this. I'm going to put a little dot 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 here. You'll see why in a second. So we're going to have a public-private pair here. I think that one of the hard things about this particular problem is thinking about the construction of the list. So how are we going to make a list of integer? Somebody has to make a call on new to actually construct this list. And one way to solve it would be to construct an array list of integer, for example, for this left-hand subtree and another one for the right-hand subtree, and then try to figure out a way to put those lists together. So we could make two different list objects and somehow put them together. That would work. That would be a way to do it. And in some sense, it's very much in the recursive spirit of it. But this would be a case where we're really only trying to come up with one of these list objects overall. So this is a case where it really is a better idea to have a single list object that's being shared by all of the different recursive calls. So that's the pattern that we want to follow. So what we're going to do here is to make a list of integer that we could call result, which is a new, we can pick whatever we wanted, but array list would be a reasonable choice to make. So we can make an array list of integer. So the idea is that we construct it once, then we are going to recurse, we'll fill that in a second, and then we're going to return that result. So instead of making a brand new one every time we make a recursive call, we'll make just one at the very beginning here. This also points out an important property of these combinations of a public-private pair of methods. This is the call that's going to begin the recursive process. And if there's anything that we want to do before that recursion begins or after that recursion is over, then we can surround the recursive call with those lines of code. So this line of code is going to be executed once before the recursion begins, and this line of code is going to be executed once the recursion is over. And that's exactly what we want. Make one list that all of the calls will share, and then after the recursion is done, return that list to the client that made a call on this. So what that means is that we're not going to have the private method returning a list object. It can be a void method. But what that also means is that we need to have an extra parameter here. We need to pass the list of integer that we're working with as a parameter to our private method. So that means the call that starts this whole thing going should pass in the overall root of the object, and it should also pass in this result. So that's how we get the whole process going, is by specifying which root is the starting point, the overall root of the tree, and what's the list that we want to work with, this array list that we just constructed right here. So again, inside of binary tree methods, we think about different cases. The usual cases to think about are an empty tree and non-empty tree. Is usually an important distinction. So we can say if root is null, then that would be an empty tree. And so we're supposed to add values to this list for all of the nodes that are in whatever tree we're passed. And if root is null, then basically there would be nothing to do. There would be no values to add into this list. So this is a case where instead of having a test on root being null, it's better to have a test on root not equal to null. And then there'll be an implied else there isn't anything to do at all. So we need to have this test so we make sure that we're testing for the empty tree. But if it is an empty tree, we have nothing to do. There's no values to add to the list that we're trying to put together here. If it is a non-empty tree, then that means that we have some root.data value to deal with, and we have left and right subtrees. Well, what are we supposed to do here? We're supposed to add values to this list so that we end up with an in-order traversal. And the in-order traversal involves dealing with root.left first, then dealing with root.data, and then dealing with root.right. So that's the order for the in-order traversal. Left-hand subtree, then the overall root, then the right-hand subtree. And what do we want to do with the left-hand subtree? Well, we want to add everything from that left-hand subtree into this list that we're forming, and that's exactly what our private method does. Our private method takes a specification of a root and a list, and it adds everything from that subtree into that list in an in-order manner. So what we want to have here is a recursive call on in-order list, passing it root.left, and of course we're going to have to also pass it that list to work with. And the same thing is true for this call involving the right-hand subtree, that we'll want to have in-order list of root.right, also passing it the list to work with. So those two recursive calls are going to deal with the left and right subtree no matter how complicated they might be. And that kind of leaves us just with the overall root itself, and we want it to be inserted into the list in between its left and right subtrees. So this one we can just do ourselves. We can just say to the list, I want you to add root.data right there. In between where we added the things from the left and where we're going to add things from the right, we want to add the value from root.data there in between those two values. So let's go ahead and compile this to make sure that we haven't introduced any errors. Let's scooch this up so that we can see it. We can come back over here to our client code and compile it. And then let's see what happens when we go ahead and run this code. And what we end up getting is we see that when the in-order traversal is a 1, we're getting a list that has just a 1. When the in-order traversal is 2, 1, we're getting a list with 2, 1, 2, 1, 3, 2, 1, 3, and so forth. This looks very good. For each of these different trees, we are getting a list that has the sequence of values matching what we got in an in-order traversal. And that's what we were asked to do here. So that turns out to be the code that solves this particular problem.